Hi everyone, I am Dhruva Bansal and I will be presenting our paper titled CopyCat Using Sign Language Recognition to Help Deaf Children Acquire Language Skills. So over 95% of deaf children today are born to hearing parents, but most hearing parents do not learn enough American Sign Language or ASL sufficiently well to teach ASL to their children. These children in turn often lack basic communication skills and short-term memory associated with language communication, leading to social isolation and language deprivation syndrome. Language deprivation syndrome is associated with a significant increase in abuse, mental health issues, and suicide. So CopyCat, an educational game, seeks to help deaf children acquire language skills required to avoid language deprivation syndrome. The game features a character which the player must sign 3 to 5 phrases to proceed. The game uses sign language recognizers as a key component to help children acquire generative language skills. So the CopyCat game uses the game UI that you can see here with a hint video performed by the instructor and a mirror of the signer. The scene that the user must describe is presented on the right. Here is a video of the complete game in operation. The scene presented corresponds to line above gray wall and the user signs it correctly. The recognition system then verifies the signing and proceeds to the next phrase. Here's a game in operation in the case of incorrect signing. The scene corresponds to snake in gray wagon, but the user signs lion above wall. The recognition algorithm realizes that and blocks the user from proceeding. A Wizard of Oz experiment conducted using the previous versions of CopyCat revealed that students who played CopyCat doubled their scores on various measures of language skills. The game's effectiveness naturally depends upon the accuracy with which it classifies sentences as correct and incorrect. Previous versions have relied on collecting data using expensive custom hardware equipped with accelerometers, along with hidden Markov models, for performing this classification. However, the need for such specialized equipment restricts the game's scale and impact due to its cost and hardware accessibility. We improve upon these previous versions by incorporating off-the-shelf cameras like Azure Kinect for data collection, thus improving the game's ubiquity and scalability. We collected 4K RGBD data from 12 adults at Georgia Tech. For our phrases, we used noun preposition noun structure with optional adjectives, such as alligator above orange wagon. We extracted hand, face, and body pose features with Google's MediaPipe, Microsoft Kinect, and AlphaPose. While MediaPipe and AlphaPose give only two-dimensional features, Kinect provides us with three-dimensional features on the user as well. Our features can be found online as we have open sourced all of our data while keeping users anonymous. We extracted feature data as input to our recognition models. We hypothesized that Hidden Markov Models are best suited for ASL recognition due to their great performance on time series and pattern recognition problems, along with low training data requirements, while compared with deep learning models such as transformers. We evaluate our recognition system on 3 pose estimators using HMMs and transformers in 3 experimental settings: user adaptive, user dependent, and user independent. Surprisingly, we find that 2D pose estimators, MediaPipe and AlphaPose, achieve parity with Kinect. We found that HMMs consistently outperform transformers in all 3 experimental settings, regardless of the pose estimator being used. Poor performance in dependent and independent settings suggests that transformers don't generalize well on the current dataset. Our codebase, along with the dataset used for this analysis, is available via our GitHub repository. Building upon the success of recognition systems, we next hope to build a verification system for performing the same task. Zohor et al. Demonstrated that their verification algorithm outperforms recognition algorithm on 3 multimodal ASL datasets. The verification system improves performance by leveraging information about the ground truth scenes themselves. Finally, we also hope to conduct a large-scale user study on deaf children to verify the educational benefits of the new CopyCat game. Thank you so much for watching our presentation. If you have questions or would like to learn more about our project, feel free to contact us.